Hey everybody, welcome back to the shop. I am ready to begin machining the new spindle for my hardtail vise. What I have here in front of me is a piece of 2.5 inch diameter 4140 steel. This is going to end up being our new spindle. This is the original spindle that was supplied with the hardtail vise. This is the same spindle that comes in Jason's Taiwan made version hardtail vise. And let me just reiterate what I said before. There is absolutely nothing wrong with this spindle whatsoever. The way it's designed, the way it's manufactured, and what it does provides a very good, strong component for Jason's vise. The reason why I'm replacing it is because this is a personal project that I'm working on. I've enjoyed machining this, putting this USA-made hardtail vise together. We have a whole series of videos already up to this point. And I've been enjoying it as a personal project, making different components and pieces for it, just like previously making the flange bolts for it and all the other custom work that we've done on it. And this is no different. I was looking at this as a fun machining project for both me to enjoy and for the viewers out there that like watching the videos on this channel. So we're going to make a spindle for it. I've never made a vise spindle before. This will be the first one I ever made. So since we're going to be replacing it, we're going to get away from this metric thread. This is a trapezoidal thread, which is nearly identical to an Acme thread. Acme being an American style of thread, generally used for lead screws, things that need fast movement and stuff like that. But this is a metric, and the best that I can measure this is 30 millimeter by 5.0 trapezoidal thread. And this is slightly smaller than 1.25 inches, which would be the standard size, closest standard size to an Acme that we're going to be going with. So you guys might have seen, we just made our new Acme nut. So we're going to be using this as our thread gauge whenever we go to thread our new spindle here. So we're going to an 1.25 inch 5 Acme thread, which is a little bit larger than this right here. And the other thing that this is going to help me with as well is this area, this shoulder area of the spindle will now be, I'll have it turned to 1.25 inches, so it'll provide a nice close fit on our thrust bearings. I am replacing both of the thrust bearings. You have two, so you have one against this flange here, and you have one on the other side inside of the dynamic jaw, which is one of the reasons why you can get so much torque on these vices here. You can really crank down on this thing because of these thrust bearings. So we're going to be replacing these guys, and we're going to be making this both a manual and CNC machining project. So to do all of the turning and the threading for the Acme, we're going to do it right here on the Precision Matthews TL1660. I have a follow rest for this lathe, so we'll pull it out of the toolbox and we'll set it up to do our turning and threading. And I am currently working on a CNC program to machine the ball end of the spindle. All right, still working on that, but I think I about got it where it needs to be. I got to do some testing on it. I got some sample stock that I'll use to turn it in the CNC and make sure we have a good solid program that's going to work and give me a good finish. I want to get that proven before we stick the threaded spindle over in the CNC. So I think that's about it. We're going to start with this. We're going to get our turning and threading done. The CNC will probably be a separate video on getting this done. And then we'll also need to, put a cross hole in it. And I'd like to make a handle for it as well. So all this stuff, I want to replace it and machine it. I'm going to video it and share it with you guys here on the channel and just continue having fun with our USA-made hardtail vise. All right, so let's get started on it. The very first thing I need to do is take the stock. It's a little bit long. This was a drop that Alro Metals had, and it's a little bit longer what I needed, but they gave me a good price on it, so I need to cut it to length, and then we're going to set it up over here in the Precision Matthews and get started on it, right? Before we cut our stock, let's go ahead and measure it, the length of it. Sure, we could use a tape measure and a scale on one end, but let's have a little bit more fun than that, shall we? This is Dad's number 123 Starrett 36-inch vernier caliper from Booth Machine Shop. This is one of those tools that just it's really special to me. I've got several of Dad's tools that he and my granddad both used, and I've got his 36-inch and 24-inch Starrett vernier calipers. And I love being able to use them. So let's use them on this job here. Let's use a little bit of Dad's tools on this passion project. Now this isn't a super critical measurement either, so we're just going to get something close and we're going to go with that. Trying to get it right on the tip of that radius down there. All right, 31 inches, 150, 5, 6, 7, 8, 158 thousandths is what I got there. So 31.158. That's pretty close to 31 3/16, right? Getting the same thing there. All right, so let's just call that 31 3/16. And I'll probably go ahead and bandsaw it at least 31 1/4. And that'll give us plenty of room to clean up the end. And then once we get this end turned and threaded, we'll be able to take it over to the CNC lathe, push it up against this flange here, and then all the remaining stock will be on that side, and we'll machine that off using the Miltronics. So 31 1/4. I better go write that down before I forget it. I'll probably have to measure it again too, but let's go ahead and get our stock cut. And we can use our Starrett 60-inch rule to go ahead and measure our cut length here. This is that one that I bought at the Florida Flywheeler show from Kenny that once belonged to Hammond, Oregon, their tool room at Hammond, Oregon. Pretty neat. So we need to make sure we're reading it the right way. I'm looking up here at 31. We wanted 31 1/4, right? I'll double check it before I cut it. 31, it's just a little bit over. There's nothing wrong with cutting this a little bit long, because once we go to the CNC, all the extra stock will be sticking out, and I'll have that measured, and the machine will know what it is, and we'll face that extra off there. So 31 1/4, maybe about a 32nd long. I think that's good. I've got the bandsaw propped up on this 2x4 because the seals in the hydraulic cylinder for the down feed, the seal has failed and all the oil has leaked out of it. So I don't have any really good control of the down feed. It won't stay up because there's no oil in the cylinder. So I do have parts to fix this from Hydmec, and I just haven't got time. I haven't spent the time getting on it yet. So I'm going to spend the day one day here and get this off, get the cylinder fixed. I want to put a fresh blade on there, clean the saw. The sump is really nasty. It's full of tramp oil and chips and everything. So it all needs to be cleaned out, put some fresh coolant. So one of these days I'm going to get over here and dedicate some time to get this fixed and get the saw cleaned up. Tell you what, let's stop that. What I'd like to do, actually, just do this. I'm going to bring this up a little bit closer. There we go. All right, let's try that again. Blade's still cutting okay, but I have dulled it because I ended up cutting through some induction hardened chrome plated rod, and I didn't realize it was hardening until I started cutting it. So it dulled the blade a little bit, but it's still cutting okay. Fortunately, the through spindle hole on this Precision Matthews is the perfect size for me to slide this 2.5 inch stock through. So we'll go ahead and face it and put our center in there too. See how it's going to run. Let's try the 620. Let's see what happens. Just fine. $30,000 face cut. I got a fresh number 3 center drill loaded up. That's what we'll use for our center. I'm keeping it kind of small because it's going to be a, 1.25" diameter. Don't want too big of a center taking up room from our turning tool. Just use a little bit of cutting oil for this. We've got this really nice Written Industries Live Center with the extended nose, the extended point on it that we'll use for this job. Nice heavy duty live center, and having the extended center allows you to get in here with these turning tools and get a little bit closer to those, especially those small diameters, but gives you a little bit of room in here whenever you're using your turning tools. I'm gonna go ahead and slide this guy out of here. I got one more tool to set up here on the chuck. Before we chuck this in, I'm gonna set it right here on the cross slide. Like that. And let me get me a rag and show you what we're gonna do right here. Since I've already got the 3-jaw on the machine, so this is what we're gonna use to support it. One of the problems with a self-centering chuck, like a 3-jaw, 6-jaw, what have you, is that you can't seem to get the same kind of clamping force on your workpiece that you would with a 4-jaw independent chuck. And so you have to be careful about pushback. Now, with this being a hot rolled material, you don't have a whole lot of worry with it pushing back. But if you're taking some heavy cuts, depending on your application, the machine, and the tool that you're using, it's really easy to push the material back, and then it comes off the center, and then you got problems. So to prevent that, since we already have our 3-jaw mounted, so we're just going to use this. But I have this chuck stop system from Edge Technology. It comes with the spider, the centering disc on the back, and the different set of parallels of different height parallels. And these are the 1/2" length. So these, you have to kind of machine these or file them, whatever, to fit the through bore of your chuck, and that keeps it in the center. You have magnets here on the back, 3 of them, to keep it sucked to the face of the chuck. And it's just a really simple tool. You stick on there like that. And now we have a positive stop that the workpiece can push against and prevent it pushing back through the chuck there. This is also really helpful if you've got workpieces that you need to do like a second facing op on, and you got a clean face that you want to push it up against something. That's really helpful for jobs like that too. I'm going to use the jib crane to help us lift this. Just because it's an awkward piece, you're having to get it into the chuck. You got to lift this side up, get the tailstock in there. So any kind of lifting equipment you can use to ease the strain off your back muscles, go for it. All right, let's see, get this in here. You can usually feel it as you're tightening up the scroll about where it needs to be. All right, get our center in there. And try not to stab it, make sure it's going to be close where it needs to be. I'm going to blow that off one more time. Okay, now the other thing I want to do, I'm going to put the tool in here, and I just See, you know, you want a little bit of run out room. So somewhere right in the middle of this gap right there is fine. You want to try to minimize your spindle stick out on your tailstock whenever you're doing any kind of heavy turning. So I can see that I've got a little bit of room there. So I'm just gonna hold up on the end of this, crank this back and bring it in there a little bit further. That's looking good right about there. So we're gonna go ahead and lock it down and then push it back. Lock that, all right. And we should be there. I like to run this jib crane around to the other side because when it's on top of the Precision Matthews, it's actually blocking one of my lights that I have up there. Now we just want to double check our torque on the chuck here and make sure it's good and tight. And we should be good. We're pushed up against at least one of those parallels anyway, because that's not a perfectly straight cut. There we have it. Okay, now one more thing that we're going to be setting up is our follow rest. That'll bolt to the cross slide right here. I'll probably go ahead and get that set up now so that it's already on there, because as we start turning this down, as we get smaller diameter on this thing, we're probably going to need the support of the follow rest to keep the chatter out of the cut. Okay, we've got the follow rest set up. Here, I'll show you what that looks like. The follow rest on this lathe here, you got these two bolts that you screw into the bottom, and these are slots, so you can literally just set it down onto the bolts, tighten those up, and we do run bronze pads on both of those there. So we'll start our cuts. We probably won't need this until we get it roughed down to a smaller diameter. So hopefully the lathe is going to react really well. This is going to be another really good test for the Precision Matthews lathe, but it's always done really well. And the other thing I was going to point out, I swapped out the chuck stop for this longer parallel that I already had set up to minimize the amount of area that the 3-jaw was clamping on, because what I noticed, because it was almost all the way back here to this, this is hot rolled material, so it's not round and it's not straight. So when you chuck on it with a self-centering chuck like that, or any chuck for that matter, if you have too much of it being held, it tries to force it to run out like this, because you're not chucking on a straight machined area. And so I noticed that the way I did have it chucked, that it was forcing it to run out over here, which can lead to issues. You know, when you take the tailstock out, you'll see it spring over to one side. You don't want that. So this one right here allowed me to chuck it minimally. We've only got maybe about an inch of it chucked up, and I bumped it very slow, and the center was very, very close to running center there. All right, so just wanted to point that out there. Let's go ahead. I'll show you our length setup. So what I did was I come in here with our tool and just very gently come up until the tool just touches the face without it running, and dialed in our DRO. I programmed a negative 27.5 length, okay? Our total length that we're gonna turn is gonna be 27 5/8. That's gonna give me 1/8 of an inch to go in there and clean that shoulder up and put a little radius in the bottom of it too. But if we come down here, I've got this this Edge Technology magback chuck on the ways here set to a 0. So when we come up and I've got the 0 at the bottom, we make 1/2 a revolution. That's going to be our stop point right there. And then from here, we'll have about 1/8 of an inch to clean that up. And then everything past this forward is going to be the meatball end of the spindle. So we want to make sure that we have a little bit over 3.5 inches here, because that's the length we need for the ball end. So I'll put my trusty hook rule up here and lay it on the tip of the tool, and we're just over 3 3/4. So that's telling me that I know I've got 1/4 of an inch there to clean this shoulder up, and also clean the end of the stock up there as well. So we should be where we need to go. And one thing I was going to do while we're down here, I was waiting to get the camera fired up. I'm going to set that 0. I like to make a witness mark. It's just nice to be able to see a visual representation of where you're wanting to stop as you're approaching that. So all I'm going to do is just run the tool up here, just like that. It's just a witness mark is all it is. So you have the DRO screaming at you, you have this witness line, and you have this dial indicator on a 0. so that you can see your approach where you need to stop. So I'm going to get the machine set up ready for a cut and see how it's going to handle this 4140. All right, we're going to get our first cut going, getting the coolant fired up. And I've got it touched off. We're going to try 125 thousandths a pass. And I've got the lathe set at a 14 thousandths feed rate, so 14 thousandths per revolution. Let's see how it's going to react to that. And I got to get my other longitudinal feed set right here. Yep. All right, here we go. Yep, wanting to chatter right off the bat, so not good at all. All right, I'm going to back up. I put a 432 insert on that because I was going to try one of those more heavy-duty inserts, but I think I'm going to go back to my 431 and give that another try. We just don't have the mass and rigidity on this machine compared to something like the American pacemaker, so it just reacts differently. All right, we'll try it again. This is where I'm going to be probably having to play with feeds and speeds and of course the insert, but I feel good about this one. This is my trusty insert that I use for just about all my turning. I'm going to see how it's going to react here. Yeah. Not liking it. All right, so let me back up and regroup here. Made some feed and speed adjustments and the depth of cut. It is just not liking it. It really is not. So I think what I need to do is focus on, let's see if we can get this just turned round, nice and straight and round, so a lighter cut, and then we can go ahead and use our steady rest, and that should help eliminate that chatter. Well, we're not off to a good start, are we? I'm gonna backed it off to a 50 thousandths pass. Let's see if that'll let us get it turned around here. I'm not using the follow rest because it's not round. We haven't turned it round. You might be able to see it. It's running out. You don't need to run a follow rest or a steady rest like that. You need to have a true surface. So that's what we're doing here. So this will take a few minutes. Let me get this. We'll get it turned, and then we'll adjust these guys up to it, and it should help eliminate that chatter. I'm gonna have to take another pass across there to clean that up. You can see we've got some low spots there. And when I got it right there, it was trying to chatter again, so I had to stop it. But I'm gonna go back across that and just take another cleanup cut to get that cut smoothed out for our steady rest. I do have another tool here that I may end up trying. This particular insert actually works really well for situations where you do have chatter, things like that. So we may give this one a try and see if it'll work too. This is a DNMG. It's a VR insert. This one's made by Ingersoll-Rand, and VR for vibration free. It worked really well before for some other jobs, and it might work good on this too. Now you can see as we get closer to the chuck here, all that chatter and stuff is going away because you have more rigidity here. Working on our second cleanup pass. If I can get it all the way down to the end without it chattering on me, we should be good to go after that. Start taking some heavier passes. All right, well, we've got it turned straight now, so we should be able to utilize our follow rest and go ahead and get some heavier passes made. Come up right here and go ahead and run this one in. Just where it touches, you don't want to push on it. All right, let's give it another shot. This is 100 thousandths deep. Got to get through this chatter here too. There we go. Now that's doing pretty good. Much better. I'm going to see if I can get a little bit of that lube on the pads as well. I think that'll work. So one of the problems that you have when you're using a follow rest and you're coming up to a shoulder is exactly that. You have a shoulder there that you're going to crash into if you try to go all the way up to the same stop every time. So that's one of the issues you'll run into when you're trying to use a follow rest. So I think what I'm going to do, since this is a little bit more rigid, let me see if it's going to handle it now. I'm going to go ahead and back off because I don't want to start rubbing the bronze on the 2.5 inch diameter. I'm probably going to stair step this thing. I'll come up and just visually stop it before the bronze gets into the shoulder, and then just keep cutting it up to that point, you know, and then we can come back and finish turning this end down a little bit, since you have more rigidity down here on the chuck end than out in the middle. All right, so right there, there's our 0. All right. So the next time we come back, I don't know, I might go ahead and back those out again and go ahead and get a little bit more of our shoulder established. But all you got to do, since we got a pretty good area here that's just going to be turned straight, I can always come back and turn this down. I don't have to turn it all at one time. And that way I can just leave the pads set to the diameter and then run it down like this, reset them, and then start another cut. All right, I swapped out that tool for that VR insert. VF, I'm sorry, it's a VF insert. Vibration free is what they call it. That's a DNMG 432 insert with a really large chip breaker groove molded into it. And it does a good job of curling that chip over, and it doesn't have quite as much tool pressure as a standard negative rake insert like I was using. I'll see if I can continue using this with the rough it down. 125 thousandths depth of cut there, and a 14 thousandths per revolution feed rate. All right, I think I'm gonna try something here. What I'd like to do is I'm gonna go ahead and raise our pads up and back. And let's go ahead and finish cutting it to that shoulder. I may just try that. All right, we're gonna call it right about there. So I'm gonna go ahead and reset my dial indicator over here. It was off a little bit. Okay, I'm just gonna back it up so it doesn't drag. So I might be able to do that right there instead of turning the stair step. I was thinking we could come up and just have a stair step and then back it off and just turn it all at one time. We can do that too. I may end up doing that. But I tell you what, that insert did a beautiful job. It did exactly like it was designed to do. I don't use it very often, but for jobs like this, it really does help when you don't have extreme rigidity that you would need for turning shafts like this. So let's reset. That was 125 on the dial. I think I'm gonna try 150 this time and see if it does well. And if it does well, we might bump it up a little bit more on the next one. All right, here we go, 150. Seems pretty good. I think we'll just keep rolling with that. I think I'll just do this, back off on them, and finish it up to that shoulder. All right, this one's gonna be 175 thousandths on the dial. Still sounding beautiful. The reason I shut the lathe off when I do this here is I'm reaching over the workpiece. You never want to reach over a rotating part. It's a good way to get your shirt caught up in the machine and wrap you up. All right. Again, that tool is working wonderfully. Glad I decided to try that one. Let's get a measurement of where we are. 1.905. So we still got a few cuts to make. So how about we go ahead and try 200 thousandths on the dial. That'll be 100 thousandths per side. And if that works fine, that's probably the max that we're going to try to take on this workpiece. All right, make sure our follow rest is ready to go. All right, here we go. 200 thousandths on the dial, 14 thousandths per revolution feed rate. It sounds great. That's a really respectful cut for the type of lathe that we're operating. And that's not me talking bad about the Precision Matthews, because I absolutely love this lathe. It is smooth, the silk works good. They're just, these newer modern lathes like this just can't seem to really handle those super heavy cuts like we're used to seeing on something like the Monarch or the Pacemaker. Check out the weather. Beautiful day here in Florida. It's not really showing you that pretty blue sky, but it's clear and cool outside today. It won't be long, that summer heat's gonna be here, so I'm enjoying it while I can with the door open. We got 300,000, a little over 300 thousandths left to bring us down to our size. We're making good headway now with this tool. All right, let's just see where we're at. I think I told you guys about 300. Yeah, 1.7. Well, I was way off. 1.7, so that'd be 450 thousandths that we still got to come off of it. But think about that. We just took a 200 thousandths pass. Now, I don't know if it's going to continue to work that well as it gets smaller, but you essentially have 2 more roughing passes and then a couple finish passes to get it to the diameter you want. Okay, another 200 thousandths pass. How about we give it a check with our micrometer here. Let's just see where we're at, and if we're turning nice and straight. There's probably going to be a little bit of deflection here in the center. That's 1.496 right here. .496 there. That's 1.498 right there in the center. So it's lifting, it's pushing at about 2 thousandths. And remember, we're removing 200 thousandths of pass there. So I feel good that once we get down to a finish cut or a couple finish cuts, it should be nice and straight. All right, so we'll just take one more 200 thousandths depth of cut on this. This will be our last roughing pass. Leave us about 40, 45 thou to come off of it. We pushed it off the center there. Trying to get it so that it both lubricates and cools the tool, workpiece, and those pads there. I think it's doing good. All that smoke you guys see, that's just steam from the hot chips. Okay, let's see if we can get this finished. I'm gonna go ahead and try the same tool since it's doing so well. I just wanna see what it's gonna do, how it's gonna react, and if it's gonna leave us a finish or if it's gonna just make curly cues everywhere. So we'll just try 25 thou and then we'll mic it and make one more pass and hopefully bring it down to 1.25 inches. All right, so far so good. We might be able to live with that. Let's see if it'll just maintain that chip. Finish is looking pretty good underneath there. That's looking good. right, this should be our final pass. Let's go ahead and mic it and see how much we need to take it down. All right, that right there is 23.5 thousandths to come off there. This end is 24 thousandths to come off there, so half a thou difference. Let's see what it is about in the middle. And that is 24.5 thousandths there in the middle there. So that's within 1/1000th of taper there. So I'm gonna shoot for the 1 1/4 1.25, this being the smallest, so I'll use this as our measurement. And I can come back over this with some emery if I need to take it down a half thou or whatever. I think that's gonna work out fine. So I'm just gonna take a couple more. 23.5, yep, it's looking pretty consistent right about there, 23.5. So I think we're gonna dial in 23.5 thou, that's gonna be our finish. All right, there we have it. Get these chips cleaned up. We'll put a mic on it, see where we landed. All right, let's put our mic on here and see where we landed. Shooting for 1.250. 1.250 exactly on that end right there. Let's see what this end's measuring. So this one's slightly under by half a thousandths. So 249.5. Let's see where it's at in the middle. This is 1 thou small right here in the center. So 249 right here, which is good. It's actually better that it's a little bit undersized. Right there, I measured at 250 exactly. That's 250. Half a thou under. Half a thou. Wow, so you got like half a thou under to about the halfway point, and then it goes to 250 for the rest of the way. That worked out great. We got a really good finish on that. It's nice and smooth. Great feel. That tool did an awesome job. I was cleaning up some of the stringy chips and I pulled some out of the chip pan and made a mess. So I'm gonna go ahead and I wanna get the floor cleaned up again. And what we're gonna do is, next phase, we'll work on this face, maybe put a little tiny undercut in there. And I'm gonna cut a thread relief in here. I'll need to measure and see where we need to put it, but I'm gonna put a nice full radius thread relief in here for our Acme thread tool to run into. That's just the way I like to do things. And we'll chamfer this in nicely as well. So that's coming up next. All right, so we got a chamfer to put here, we got our undercut and our face to finish. We'll go ahead and start with this chamfer. I've got the follow rest on there to support it. All right, just like that. What I'm going to do is use our DRO to measure the length of it. So I'm going to put my other facing tool back in here like so. I'm just going to come up to that face, just touch it like that, and I'm just going to zero that. All right, that's 0. So we want 20, 27 and 5/8. I'm going to have to back these up again. Leave a little bit down in the bottom corner so I can go in there with a radius tool and probably make a little small undercut down in there. Let's see where we're at. Yep, so that's 27.5, which is where we had set that. So I'm going to go ahead and bring this up to 27. I'm going to give myself a little bit of room there to face that off like 10 thou. All right, so there's 27.615, and then we're going to set this 0 right here. Like that, and then that's what we got to face off. No, come on. That ain't what we want. Too much speed, not enough feed. Let's see. That might help right here. Still ain't breaking a chip. All right. Just leaving a little bit of material down in there so that I can make sure that it does clean up. It doesn't leave a sharp edge in there. That face looks good though. All right, there's our corner radius. All right, so we just put our radius in the corner there. We got our bevel done, so I want to go ahead and cut a thread relief here so that when we're threading it, place for the tool to run out, Plus it puts a nice pretty radius down in there. So whoever made this one, they have it approximately, if the tape will stay, about 19.5 or so. So I think what I'm gonna do, I'm just gonna make it an even 20 inches there. This right here, this is no big deal. This is just, there's nothing here. The thrust bearing slides up, and then you have a spring and a lock collar on there as well. So I think we'll just make ours 20 inches to the edge of the groove, and we'll make like a nice wide, like maybe a good 1/4 inch wide groove down in there for our thread relief. So let's go ahead and get that done. We'll use our DRO again to measure this. So I'm gonna bring our tool. That's a 1/8 wide full radius tool in there. I'm using that Walter, that's the MX22. I love those tools. So we're just gonna bring the tip up just so it touches the face. So we'll come up here on the DRO. We'll do a -20. And we'll bring that down to 0. Just line that up on 0 right there. And I'm going to make the width of the groove that way. So we'll set a 0 over here with our dial indicator as well. Calculate what the depth needs to be, and we'll go ahead and get that cut. All right, we got our tool where we want. I've got the diameter set at 1 1/4 inches. We're going to be taking this down to 1 inch 30 thousandths, the diameter of our undercut. We're going to go ahead and use our follow rest here, because it will chatter if we don't. All right, I'm going to back the tool off. I need to get the RPM set, and let's get it cut. Oh, come on. And get underneath it. Go ahead and widen it out a little bit. All right, there's our diameter. We're going to turn it across. All right, that should be our thread relief right there.